All right, cool. Hello, everybody. My name's Omer, and what I'm about to show you is my new radio project. I like to think that the best projects speak for themselves. And in this case, it can do it in the most literal sense ever. Take a listen.
Good day, everyone. This is Sybil on Radio Ether, bringing you the latest buzz. It's September 5th, 2024, and the annual BBD Escape Conference has begun. Breaking news. Omer Elgoni, a visionary technologist, has made headlines by creating an AI-powered radio system entirely in the cloud without going bankrupt. Omer is soon set to give an exciting talk, revealing the secrets behind his innovative creation, the tech wizardry involved, and how he managed to keep his expenses under control. Stay tuned to Radio Ether for more updates on this groundbreaking achievement.
So what you just heard was a snippet from my new project, Radio Ether. It's an online radio, and today we're going to be discussing what it is, why I built it, how I built it, and what challenges I ran into along the way, which were mostly monetary. So yeah, let's jump into it. So, what is it? The first thing it is configurable. You can choose what news you listen to and what music you listen to. It is self-hosted, T's and C's apply, we'll talk about that later. It is cheap, this was the most important criteria. And it is an online radio. It tells you the news and it plays music and everyone can listen to it through the internet. But let's talk about why I built this. So, since I was young, I used to listen to the news in the car. When my dad drove me to school, and now that I drive myself, I still listen to the news and the music in the car. But not all news they play on the radio is relevant to me. For example, I care about politics, I care about tech, I don't really care who won Wimbledon this year. And frankly, I don't know if you guys listen to radio, but the music they play is not really my taste. So what if I could choose my music? What if I could choose the news that I listen to? I really, really like this idea. But I had no idea how to achieve this. So let's talk about how we build a radio. I'm going to take you through the steps that I took, thinking what makes a radio and how can we reproduce that with code. So yeah, I stepped into my lab. This is what I'd like to imagine I looked like, but more accurately, it was me sitting in front of my PC at 1 a.m. in the morning thinking, what makes a radio? What even is a radio? So let's go through the process, from the planning stages all the way through to the final product. What does a radio need? The most important thing that a radio needs is news. We need to gather news, and it needs to not only be up to date, but it also needs to be relevant to whatever we want. So we need to choose news that we care about. Next, we need to summarize the articles and tie them together into a coherent bulletin. Many articles are very long and have a lot of detail in them, and we only want a 5-minute bulletin. We don't want to listen to 30 minutes of audio for each story. So yes, we need to summarize. Then finally, we need sound. We need to play music every 30 minutes between bulletins, and we need the bulletins to be read out aloud in a human voice. I don't want to listen to a robot, and I don't want to have to read while I'm driving. That's pretty dangerous. Don't do it. Cool, so these are the 3 steps we need to build our radio. Let's go through them. How do we gather news? Gathering news is fairly simple. There's this thing called RSS, which stands for Real Simple Syndication. And it is a source that many news sources online provide to us that allows us to get their latest articles with a link to the article, the title of the article, and sometimes they even give us summaries of the articles, though not enough for it to be reliable. And RSS can provide for a lot of things. You can do news sites, you can do people's tweets, you can even do your GitHub commits if you really were inclined to do so. I haven't tried that yet, but if anybody connects their GitHub to a radio, I think that's really cool. But like I said, we only get summaries sometimes. We need to get the website content in a clean text-only format after following the link. Unfortunately, many websites today look something like this. It's a pain. We have cookie pop-ups, we have ads, we have social media links, there's sidebars, there's a lot happening on screen. And I don't want to listen to my radio saying, you can follow TechCrunch at LinkedIn on www.linkedin. I don't want to hear any of that noise. I also don't want to hear about ads, and we just need clean text. Wouldn't it be better if our websites looked something like this? This is my browser's reader mode, and it is way, way cleaner. All we have is a title, an image, and then the important relevant text of the article. But this radio is running on a server. It's not running inside my browser. How can we replicate this in code? Turns out, it's super easy. Mozilla, the company behind Firefox, has actually open sourced their algorithm for the reader mode. They call it readability.js. And what this is a library that we can pass in a link and it will return to us the contents of the reader mode. We ignore the images and now we have pure text. That's great for us. But now what we need to do is summarize the news. We don't want to listen to 30 minutes of audio. We just want to change all of these paragraphs into one simple short bulletin. We need some way of turning a lot of words into a few words. We need a summary. This is summary.com, and it provides a summarization algorithm that works with a simple heuristic. It reads the entire text of the original article and extracts keywords from each of the sentences. It then picks the top n sentences, which is configurable, and just simply repeats those parrot fashion back to you. It's really, really easy to implement. In fact, so easy to implement that way back 7 years ago now, wow, I'm getting old, I implemented this as a first year in university when I barely knew how to code, and it's still on my GitHub today. It's actually my second repo that I ever put on GitHub publicly. But the summary algorithm has a few issues. First up, it can only repeat sentences that already exist in the text. Secondly, it provides low-quality summaries some of the time. Not everything can be summarized with such a simple method. Third, it can't connect the stories in the bulletin together. And finally, how are we going to manage the intro and the outro to the bulletin? Our radio host needs to introduce themselves, and they need to say goodbye at the end of the bulletin. If only there were some other algorithm that could handle all of these natural language problems like summarization and coming up with an intro or outro. We need an algorithm which is very easy to run. An algorithm which can generate new text to link our stories together. And finally, I needed an algorithm which allows me to put the buzzword of the month in my talk title. You guys guessed it right, ChatGPT is involved. If you've been under a rock for 4 years, ChatGPT is a fancy large language model, which is an AI model that can understand language the same way humans do. Or at least that's what they tell us. It's a bit more complex, but this isn't an AI talk, so I won't be explaining how it works. And it entirely solves our summarization problem and even allows us to compile the bulletin with intros and outros. It's perfect. This is how simple it is to summarize an article using GPT, by the way. It's literally 5 lines of code. So now we have our summaries, we have our text for our stories. The last thing we need is the voiceover for them. And that is also pretty simple. There are many online websites that provide text-to-speech services. The undisputed leader at the moment is called 11 Labs. But there are a lot of them in this space. There's Amazon Polly from AWS. Microsoft has their own Azure Speech. Google has their own Speech Cloud API. And finally, there's even open source versions like Piper, which is designed to run on a Raspberry Pi and completely trained by the community. I ended up choosing Piper because it is open source and, like I mentioned, designed to run in real time, which means it can generate the text faster than you can listen to it, or it can generate the voice faster than you can listen to it. It also has the best balance of quality to cost, the cost being free and the quality being decent. Here's what that sounds like.
A rainbow is a meteorological phenomenon that is caused by reflection, refraction, and dispersion of light in water droplets, resulting in a spectrum of light appearing in the sky.
So you might have noticed that this doesn't sound like my bulletin from the start of the talk. And that's because I spent so long working on this project that in between starting with Piper, OpenAI released their own text-to-speech, which is also just 5 lines of API call. And it is way, way, way higher quality, as you heard in the start. So I went forward with this one. So now we have all the parts necessary for our radio. Let's look at what our final architecture looks like. We have RSS feeds in readability.js to get the news articles from a website. We can summarize our articles by sending them to ChatGPT. We can use the same OpenAI endpoint to generate the voiceovers and send them back to our server. And finally, we just stick all of these together and send it off to our client. It worked perfectly. In fact, this architecture is barely different from the final version in terms of its quality and its performance. At long last, we have AI-powered radio in the cloud. But like all things, it comes with a cost. a very, very steep and very personal cost to me. And that cost is, of course, money. This is what it took, or this is what it cost me to run this for 1 hour. That is 2 bulletins. 59 cents, or $59 cents. Let's do some maths. To run this 24/7 would cost me $28.32 per day, because that's 2 bulletins per hour, 24 hours. $28.32 per day is closer to $850 per month. This is not a good use of money. As they say, this is not stonks. So how did I avoid having my wallet look like this? Which it does, coincidentally, but that's related to my Lego addiction, not to my side project addiction. Let's go through it. So the first thing was a major realization that storage is a lot cheaper than AI. We can simply cache our results into a database, and then we don't need to call OpenAI every time we want to make a bulletin. And I did this in a really simple way. All I did was attach an SQLite database to my server, and this is what that looks like now. We summarize the articles, we generate the voiceover, and we store that in a database. And then when we want to generate the bulletin, we just reuse these voiceovers from this database. But that complicates how we generate our bulletins. We can't just send it in a single prompt, we now need to do something more sophisticated. Previously, how it worked is we would simply send all of our summaries to ChatGPT in a single prompt and say, compile a bulletin, get that bulletin, generate a voiceover, and send that straight to our client. But now, instead of sending summaries to ChatGPT, we get a bunch of voiceovers from our database. And we need to splice them dynamically into the bulletin. We do this using a slightly more sophisticated prompt. We generate audios for intros to the story and intros to the bulletin, and then we just mix in the pre-recorded voiceovers. And this reduces the amount of voiceover we need to generate from a full 5 minutes to just about 30 seconds. Here's what that final prompt looks like, by the way. I don't know if it comes across well on screen, but it is a good deal more complicated, but it does its job beautifully. This alone decreased our price by almost 80%. And yes, as they say, this is stonks. The voiceover is actually the bulk of the cost, so this caching was super duper effective. I did do another optimization on this. I spent so long on this project that OpenAI released not 1, but 2 iterations of ChatGPT in that time. And my costs went down dramatically. I don't recommend doing that, waiting that is, because it's not very good for production. But after all of this waiting and all of this optimization, this is what my costs look like today. That's $0.75 for a full 24-hour day's worth of bulletin. And that's just with this one optimization. So let's bring up my board again. Let's do some more maths. We've gone from $28.32 to $0.75 per day. That's pretty good savings. I think it comes up to about $23 per month. But that wasn't all the costs we have. We still need to talk about hosting. After all, this is AI-powered radio in the cloud. So we saved a ton of money by restructuring how we use our API, but hosting is still pretty expensive. It's very expensive. There's a joke I love, and I'm going to share it with you on screen now. So there's a genie who approaches a man and says, I'll give you $1 billion if you can spend 100 million of that in a month. And there are only 3 rules. No gifting the money, no gambling with the money, and no throwing it away. And the engineer who the genie was speaking to says, can I use AWS? And the genie simply says, now there are 4 rules. AWS is expensive. So let's talk about why that was so expensive. This is my initial iteration of the project. We have a server and we open up a new audio stream in RAM for each user that connects. And we send them 10 minutes of audio at a time. It has some issues. One is that it uses 100 megabytes plus of RAM per user. If you have 1 user, it's 100 megs. Easy, chilled. If you have 5 users, it's 500 megs. Getting a little worried. If you have 10 users, 100 users, 1,000 users, suddenly you're going bankrupt from using AWS and your computer looks something like this. I don't want to roast marshmallows on my PC. So let's refine this. we made a new architecture. There's just one audio stream in memory, and we send users chunks of a few kilobytes at a time when they connect. This way, our RAM usage went down quite a bit. No longer in the range of 100 megabytes per user, we are now using about 1 megabyte per user. And this was costing me about $5 per month to host using a service called fly.io. Strongly recommend them, they're great. But $5 is, can we get that down? The answer is yes, we can. But let's talk about how we do that. It's well known that the cloud is simply someone else's server. It's not some mystical thing in the sky. It's just a server in a data center somewhere, and we're just loaning it. This server has a singular purpose. And that singular purpose is to turn your money into someone else's money. And sometimes they are scarily good at this. What I'm showing you on screen now is an article called How I Got Pwned by My Cloud Costs. It's written by Troy Hunt, who runs a service called haveibeenpwned.com. And this service simply tells you, are your passwords leaked? Many people use it. It's integrated into many browsers like Microsoft Edge these days. This man is an elite software developer with years and years of experience. And still, 1 month, his costs looked like this. If you can't read that, in the first 2 weeks of the month, he spent about $50. In the last 2 weeks of the month, he spent $12,000. Sorry, those are Australian dollars, not US dollars. But still, that's a lot of money. And I don't have that kind of money. So how can I prevent this? I did my research, and one thing we could do is pre-reserve our cloud instance. This way, we pay upfront, and if we overrun this, it simply shuts down the service. And I ended up finding a pretty good cloud service where I could reserve a node with a quad-core processor, 8 gigs of RAM. For the next couple of years, this would exclusively be my server. And all of this cost me only about 1,500 Rand. It's a pretty sweet deal. That service is, of course, just me going out and buying a Raspberry Pi. It's cheaper than the cloud, and I can just run it at home. It doesn't have 99.99% uptime, but it works for what we're doing. We still had a scaling problem, though. What if there were some event in the future which would spike my load by introducing a whole bunch of new users? Something like giving a talk at a tech conference, maybe? Nah, never. That would never happen. I can't just go out and buy a bunch more pies when my demand goes up. So I had to fix the scaling problem. And it got me thinking about the cloud again. The cloud is just someone else's PC. But now I'm using my own PC. Can I invert the second part of that? Instead of paying someone else money, can I get someone to pay me money? This sounds made up. It sounds ridiculous. But as it turns out, there are multiple services out there which will handle my infinite scaling issue. And in fact, they will even pay me if I scale high enough. These services are naturally YouTube and Twitch and other streaming websites. The cheapest way to pay for anything is to get someone else to pay for it. And both of these sites are infinitely scalable, at least for my purposes. If I ever get so many users that I can bring down YouTube or Twitch, I'd be very, very, very happy. Furthermore, there's no hosting fees for hosting my stream here, and it even handles all the concurrency issues for us. So what does the final version of this project look like now that we've solved all of our monetary costs? Well, what I was envisioning was something like this. But what I ended up with looks like this. This is Radio Ether. It's currently a Twitch stream that is running 24/7. It's got a plain black background. And the reason for this is that my little Raspberry Pi could not keep up with video encoding, so I just used a black background to save on processing power. I'm pretty sure I made a mistake somewhere in the encoding process, but we'll fix it. Maybe by the time you're watching this, it's even fixed already. So remember, that's twitch.tv/Radio Ether. Please like and subscribe. But let's see, what does that actually look like?
Prompting an investigation into its safety for return flights. If deemed unsafe, the astronauts would return on a SpaceX capsule, raising questions about Boeing's future in the commercial space flight sector after a significant investment. The decision will impact the dynamics of U.S. manned spaceflight as NASA has financially supported both programs and aims to maintain two transportation providers. The announcement is set for 10 a.m. Pacific Time on Saturday. Moving on, we have some news from the economy. America's space industry is robust, but its supply chain, particularly for spacecraft components, is lagging.
So yeah, that's what it looks like live today. You can go look at it and hopefully it's still up. But there were further optimizations I considered. If I'm already running the server on my own hardware, could I run GPT on my own hardware? And it turns out you can. There is a project called Llama, it's by Facebook, and it's an open source implementation of the GPT algorithm. It's easy to host on your hardware, if you have the right hardware. This sounded way better than paying OpenAI for API calls. So I decided to look up how much the right hardware to run Llama would cost. What you need is a GPU, and you need a pretty beefy GPU. So I went there to amazon.co.za and decided to check how much it cost. And yes, this is 100% a legit screenshot. It costs too much. It is absolutely not worth the cost. GPUs are way, way, way too expensive, and you have to spend money on electricity. And I did the math. It's not worth it. I'd spend more on a GPU than I would spend on years and years of OpenAI API calls. The next thing I considered was simply running the text-to-speech myself using Piper, our old friend. And this would reduce my costs by about 90% at this point. This is tempting, but it compromises the quality of the project a bit too much for my liking. So I left it out. So yeah, we've gone from a cost of $850 at the start of the month to only about $22 or $23, depending on how it shakes out at the end of the project. So let's get into my final 4 tips to avoid bankruptcy. The first one is simply optimize, optimize, optimize. Good code is cheap code. If you spend the time to write good code, you will reap the rewards in your wallet. And then maybe you can go out and buy more Lego like I did. The next tip is to use the right tool for the job. Sometimes we're tempted to use all the coolest tech, all the newest tech, but simpler approaches work as well. So do your research well and choose what works for your project. Next is to consider hosting your own server. The cloud is great, we use it for a lot of things these days, but it isn't the best for all projects. We don't need 99.99% uptime. We don't need 3 different availability zones. We don't need to be on the edge close to our users. We don't need any of that. So just think about it. If it's right for your project, use the cloud, but if it's not, host your own. And the final tip is to just consider leaving out some features. There were a lot of things I wanted to build for this radio, but complexity implies costs. The more complex your project is, the more features you have, the more expensive it's going to be. Sometimes you can just reduce the quality of your project a little bit, and then you can get massive savings. So yeah, here is the final slide with all the information you need to take away from this talk. I hope you enjoyed it. Thanks for listening.